Welcome to Video Notes with Maymay. My topic is finding domain algebraically and graphically. So my name is me, date is today. Following tradition. So the key question here is, what are we looking for when we're finding for the domain? So we're looking for the values of x that make the function undefined. Because we can't have our function be undefined. And there's two ways that you can make a function undefined or anything undefined. And that is having a 0 in the denominator because 1 divided by 0 is undefined. So if f of x equals 1 over x and x equals 0, then that makes the function undefined. So the other way is to have a negative number in an even root. So say it's 4, or it's the fourth root of -1. That is undefined because you can't have, if it was the cubed root of -8, it would be just -2, but with any even root, you can't have a negative number because a negative times a negative is a positive. There's no way to get to a negative number, so there's no way to divide out of it. So that is why there can't be an even root with a negative number inside of it. So if you have a function with an even root, you just have to make sure that x is not a value that could make it the whole thing negative. So for key vocabulary, the domain is the set of all real numbers for which the expression is defined. The denominator is the lower half of a fraction. And an even root is any root with an even index. And reminder that the index is this part of the radical. So to find it algebraically, first we're just going to factor whatever is in the denominator, because you have to sort of break it up to see what could make this equal to 0. So we can just guess and check. I know it's going to be x minus and x plus, and the bigger number is going to go here. So it's x minus 10x plus 3. And check that. Yeah, minus 30. So then we're going to set each of our factors equal to 0 to see what could make this possibly be 0. So add 10 to both sides, x equals 10. But actually what that means is that x can't equal 10. And then x plus 3 equals 0, minus 3, x equals -3. And then we can, or x doesn't equal -3. And then we can write that in interval notation. So it's -infinity to -3, because it could be any value in between. It just can't be those specific values. Union -3 to 10. Union 10 to infinity. So that is the first problem. The second one, we have an even root problem and a denominator problem. So we have to set it greater than 0, not greater than or equal to, because it can't be 0 and it also can't be a negative, it also can't be a negative number. Usually this would include 0, it could be greater than or equal to 0, but it can't because there's also a denominator issue, and this is in the denominator. So we're going to set 6 minus x greater than 0, minus 6, negative x is greater than negative 6, and then when we divide by a negative number, we have to swap the sign with inequalities for reasons I will never understand. So it's x is less than 6. So the writing that in interval notation is negative infinity to 6. And that is that problem. And then this one, you just set each of these factors equal to 0, so x plus 2, or is greater than or equal to, 0, and then x plus 3 is greater than or equal to 0, because now there's no denominator issue, so you can just set it greater than or equal to minus 2, minus 3, x greater than or equal to negative 2, x greater than or equal to negative 3, and then the final interval notation is negative infinity to negative 3, union negative 3 to negative 2, union negative 2 to infinity. And that is it for video 1 of 3 of these video notes. See you on the next one.